Welcome to another edition of RCE. Again, this is Brock Palen. You can find us online at rce-cast.com. You can find a link to all of our blogs, all of our Twitters, and our entire back catalog of over 100 episodes on scientific computing, engineering, and other things. I have again here Jeff Squyres from Cisco Systems and one of the authors of OpenMPI. Jeff, thanks for your time.
Hey, Brock, how's it going?
Good. Before we roll into this, I do want to make a small announcement. I have a little bit of a different job opening available right now in Ann Arbor at the University of Michigan, developing using containers and container orchestration software for big data. So if somebody has experience with Docker, Mesos, Kubernetes, or anything like that, hit me up. You can find contact information on the website at rce-cast.com and let us know if you're interested in that position.
All right, with that administrative note, let's jump right into it today. Today we've actually got 3 guests on here, and we're going to be talking about the SAGE2 project. So, gentlemen, I wonder if you could introduce yourselves.
Hi, my name is Jason Lee from the Laboratory for Advanced Visualization and Applications at the University of Hawaii.
Hi, my name is Kobayashi. I'm a student under Jason Lee. I'm working towards my PhD in computer sciences, and I've been working with the SAGE2 project for about 2 years now.
And I'm Luc Renambot, a research associate professor at the University of Illinois at Chicago at the Electronic Visualization Lab.
Okay, so we're here to talk about SAGE. So I've been following SAGE for a while. Can you guys give me an overview of what SAGE2 is?
So SAGE2, as the name implies, is the second generation of SAGE. And what SAGE was essentially a piece of middleware that allows you to drive large display walls as if they're one contiguous canvas, allowing you to post visualizations and information onto those walls. Whereas SAGE was all written in C++, the new SAGE2 architecture is entirely redone in Node.js and JavaScript technologies.
So what motivated you to switch from C and C++ to Node.js? Why not? Because, off the top of my head, it would seem that C and C++ would be a much higher performing language and have better optimization possibilities than the other technologies you cited.
So part of it was actually an experiment. We had started noticing that computer graphics on browsers were starting to get powerful enough to be able to do something real as opposed to just little video games. And in a little experiment, we decided to write just a small piece of test code to see how well it performed for a SAGE-like task. And then we said, well, let's go full tilt and see what would happen if we try to port the entire SAGE architecture to it. And surprisingly, it worked very well. And on top of that, we get the benefit of leveraging a lot of the JavaScript infrastructure and a lot of the tools that this large community has already been developing.
So what are some use cases then for SAGE or SAGE2? What kind of, wow, let me do that again entirely. Let's pretend we're still on the break and I'm going to just start again. So what are some of the use cases for SAGE2? I mean, why would you buy a video wall, and what are some things that you would want to display on it?
The community of users that we work with typically have large amounts of data, and they produce visualizations of them. And just one picture doesn't give you the answer to the research question they're looking at. Usually, it's a bunch of different images from different data sets, and they're trying to put it all together like a giant jigsaw puzzle, so that they can come up with whatever story is hiding behind all this data. It's very typical for users to come to a meeting room with the large SAGE walls and start throwing information onto the walls and talking about them. Or they would form a little meetings where, as part of a research meeting, people would come in and deposit information onto the walls and have discussions.
Okay, so most of the time when I see display walls being touted, they're always talking about how many megapixel it is, and they always have one giant image of, the cosmic background radiation or something like that. But you're saying the most common use case is actually to generally have multiple images up there through time or different variables for the same simulation. What's the goal here? Is this a productivity boost for researchers or just a nicety?
Yeah, it's both a productivity boost, but also a creativity boost, right? When I teach classes, for example, using SAGE, I often give my students a data set, and then when they come back, I ask them, well, what have you been able to visualize with this data set? And then they can throw up all the different approaches that they've come up with to visualize the data, like a giant pinup board. And then we can discuss them, like why did you choose to use color to represent this particular attribute versus, size, right? And you're absolutely right. Historically, large display walls were typically used to drive one giant picture, right, at very high resolution. And that made sense in the past because part of it was pushed by the HPC world, where we had enormous amounts of data and we wanted to try to produce the best visualization possible using the highest resolution lens possible. But as people start becoming more productive and trying to use these displays, they thought, well, why don't we have our cake and eat it too? Throw both high resolution content, but also lots of it, because frankly, there is just so much different types of data that they have to look at.
Okay, so let's jump back a little bit here. What exactly is the relationship between the University of Illinois at Chicago and the University of Hawaii at Manoa, where you guys are working? Because clearly we have two groups of you on today. What is the breakout here? How do you guys collaborate?
I was previously the director of the lab in Chicago, and I was professor at UIC before I moved to Hawaii, just because the weather is so much more awesome here. And so this project was something that we began back in Chicago as far back as 2004. And so this is just a continuation of that project.
Okay, so you said in the past people were just driving large megapixel displays. There was another project that appears to be dead now called Chromium. Is there any relationship between SAGE and Chromium? Different philosophy? Two people trying to do the same thing? What's going on?
Yeah, so Chromium was really an implementation of OpenGL over the network, if you want to see it. The goal was kind of the same. You wanted to drive large display wall with real-time graphics. And one approach was to basically send the OpenGL commands to the display nodes directly. But that's a model that Jason described where people were putting large amount of effort to drive the wall with one application, displaying a large simulation result, for instance. And if you wanted to see the second simulation result, you have to stop the application and start another one, or something like that. And when you compare to how you really work, that's not the way you work on your laptop, for instance. How many applications do you have open when you try to solve a problem? You have email, you have an Office suite, you have a simulation package, you have statistics, and so on and so on. So people do not work with just looking at one image or one representation. You want to see multiple images, multiple views of the same data set, or multiple data set from last week or the previous run of the simulation, and so on. So that was one goal of SAGE, was trying to let you show multiple data set at once and leveraging those high resolution walls, not just for demonstration, but for actual work.
So how does this work? What is the architecture here? Do you have to have a dedicated server set up and you send the output of each application to the server who then projects it to the wall?
So yes, so the SAGE1 model was really pure streaming. So there was an application was rendered on one machine and we were streaming pixel to the display nodes. And then when we saw the power afforded by the browsers, we changed that model and say, let's try to do the rendering inside the browser. So now we have some kind of web server in the middle that manages all the resources, but the rendering is done on the display side. So
you talked about having multiple applications in the way you work on a normal machine. I'm sitting at my desk here and I've got my laptop with two 27-inch displays hooked up to it, but I'm out of ports to be able to connect stuff. If I wanted to have more, could I use SAGE just with my normal machine and have more email and more terminals and more things? Does that work? Or you just talked about having a web server. Does everything have to be a web app?
Yes, yes. One trade-off was to say, let's try to use only web development tools to drive those display walls, because we gain a lot by using the browser as a runtime system. So we leverage the audio APIs, 3D rendering API, and